Hi, my name is Charles Kaplan. I'm professor at the State University of New York at Old Westbury, and this particular video is the second of two videos in which I describe how to differentiate fractions where there's numbers in the numerator and variables in the denominator. And we do this using the power rule and the chain rule. The chain rule if we have e to the something in the denominator, and the power rule if we just have x in there. And I'm going to show you how to do this easily. Okay, by the way, the first video has more simple basic examples in it. This video, the second video, has more sophisticated problems in it. But they're all pretty easy, as you'll see. The trick to this is to pull out the 5/4 in this case. So this is equal to 5 over 4 times 1 over e to the 2x. And now we're going to move e to the 2x out of the denominator. So y is equal to 5 over 4 e to the negative 2x. And now we're ready to differentiate using the power rule. Using the chain rule. Remember, the chain rule in this case is e to the u times u prime, where e to the u is the function and u prime is the derivative of the exponent. So y prime is equal to, let's rewrite this, 5 over 4 e to the negative 2x, and we're going to multiply it by u prime, the derivative of the exponent, or negative 2x, which is negative 2. So let's clean this up a bit. Y prime is equal to negative 10 over 4 e to the negative 2x, and we know that negative 10 over 4 is negative 5 over 2, so y prime is equal to negative 5 over 2 e to the negative 2x, and now let's move the e to the negative 2x down into the denominator, and we get y prime is equal to negative 5 over 2e to the 2x. Remember to lose the negative sign in the exponent when you bring it down into the denominator. It's a minor thing, but it changes the problem if you don't do that. Okay, so here's the next problem. Y equals 2 over 5e to the 4x cubed. And we can pull out the 2/5, which we're going to do here, times 1 over e to the 4x cubed. I just want to let you know that when I'm doing this on my own, I just blow through this step and I go right to the part we're doing now, which is 2 over 5 times e to the negative 4x cubed. This component here, it's a little superfluous. I do it here just so that you can see each and every step I go through to get here. Okay, so now we're going to differentiate this. Remember, it's going to be e to the u times u prime. So y prime is equal to 2/5 e to the negative 4x cubed times, the derivative of negative 4x cubed is negative 12x squared. So y prime is equal to negative 12x squared times 2 is negative 24x squared over 5 times e to the negative 4x cubed. Now we're going to move e to the negative 4x cubed into the denominator. So y prime is equal to negative 24x squared over 5e to the, I almost did it myself, 4x cubed. And that's it. We're all finished with this particular differentiation. Okay, let's move on to the next one. F of x equals 5 over 3 times the square root of x. Well, we're going to pull out the 5/3. 5/3 times, and now that's 1 over the square root of x. Remember, if we multiply this through, 5 times 1 is 5, and 3 times the square root of x is 3 root x. So this is how we pull out the fraction, and how we start to rewrite these things. F of x is equal to, we can rewrite square root of x as x to the 1/2, 5/3 times 1 over x to the 1/2, and that can be rewritten as 5/3 x to the negative 1/2, and here's the piece we're differentiating. So f prime of x is equal to, negative 1/2 times 5/3 is negative 5 over 6, x to the negative 3/2. Remember, we're subtracting 1 from the exponent, And 1 can be rewritten as 2 over 2. So x to the negative 1/2. Negative 1/2 minus 2 halves is negative 3 halves, and that's how we get that particular exponent. Now we can clean this up. F prime x is equal to negative 5 over 6 times x to the 3 halves. And there's our derivative. Not very hard. Okay, here's the next problem. Y equals 5 over 3x squared. Here we cannot pull out the 5 over 3 because we're squaring the 3x. It's in parentheses here, so we're going to have to square out the denominator, which is 9x squared, and there's our 5 in the numerator. Now we can pull out the 5/9. So y is equal to 5 over 9 times 1 over x squared, and that can be rewritten as 5/9 x to the negative 2. Now we can use the power rule to differentiate this function right here. So y prime is equal to, well, negative 2 times 5 is negative 10 over 9x to the negative 3. And we can move x to the negative 3 down into the denominator, so y prime is equal to negative 10 over 9x cubed. And there's this particular derivative. We've knocked off another one. Okay, let's move on to the next problem. We have 4 over 9e to the 9x cubed. Well, we can pull out the 4/9 here. 4 over 9 times 1 over e to the 9x cubed. E to the 9x cubed. And now we can kick e to the 9x cubed out of the denominator. So h of x is equal to 4 over 9 e to the negative 9x cubed. And that's the function we're going to differentiate. So h prime of x is equal to, remember, this is e to the u times u prime. So we're going to rewrite the function 4 over 9 e to the negative 9x cubed. And we're going to multiply by the derivative of the exponent, negative 9x cubed. And the derivative is negative 27x squared. And we can clean this up now. H prime of x is equal to negative 27x squared times 4. Let's see, negative 27 times 2 is 54 times 2 again is 108. So we have negative 108x squared over 9 times e to the negative 9x cubed. And now we can reduce 9 into 108 because 12 times. So h prime x is equal to negative 12x squared times e to the negative 9x cubed. And now we're going to kick e to the negative 9x cubed into the denominator. So h prime of x is equal to negative 12x squared over e to the 9x cubed. And that knocks off another one. So here's this derivative. And let's move on. I've got 2 more, I believe. So, okay, here we have y equals 4 over 5x to the 5 halves. We're going to pull out the 4/5 here. And we're going to multiply by 1 over x to the 5 halves. And now we're going to kick x to the 5 halves out of the denominator. So y is equal to 4 over 5 times x to the negative 5 over 2. And now it's just a simple power rule problem to differentiate. Y prime is equal to, well, negative 5 over 2 times 4/5 is negative 20 over 10. X to the, well, negative 5 halves minus 2 halves, is, which is 1, is negative 7 halves. And 20 over 10 reduces to 2. Y prime is equal to negative 2x to the negative 7 halves. Therefore, y prime is equal to negative 2 over x to the 7 halves. And that takes care of this derivative. And I believe I have one last derivative to do, one last example. And this is y equals 4 over 5e to the 3x to the 5th. So we can pull out the 4/5, and we're going to multiply it by 1 over e to the 3x to the 5th. And y is equal to 4 over 5 e to the negative 3x to the 5th. And remember, this is e to the u times u prime as the derivative. Therefore, y is equal to 4 over 5 e to the negative 3x to the 5th times the derivative of negative 3x to the 5th, which is negative 15x to the 4th. So we're going to multiply this by 4/5. Y prime is equal to negative 60x to the 4th over 5 times e to the negative 3x to the 5th. 60 over 5 reduces to 12. So y prime is equal to negative 12x to the 4th, e to the negative 3x to the 5th. And now we're going to kick e to the negative 3x to the 5th into the denominator. So y prime is equal to negative 12x to the 4th divided by e to the 3x to the 5th. So there's the last one. Once again, my name is Charles Kaplan. If you found this video helpful, I'd appreciate it if you leave some nice comments. Otherwise, I wish you all good health, good happiness, long lives, and a lot of luck. Bye-bye.